My friends, today is a magical day where we get to introduce the wonder of open source game development. Welcome, welcome. Come in, get cozy. So today we are talking about Godot, Godot, however you would like to say it. And that brings us to this question: what is a game engine? Well, you all know what games are, I would hope. A game engine is a piece of software that gives us lots of tools in our tool belt to create fun projects without having to worry too much about the superfluous details. So we can spend more time creating beautiful things. So why not just code everything yourself, right? You get more choice and you get more freedom over whatever it is you're making, right? Well, that's basically overkill. Why would you use, I don't know, like a fire hose to water your garden? Do you have a question?
Or water my fires.
More of a comment. I will say I kind of half built my own like visual novel system from scratch within another game engine.
Yeah.
When I went to RedPie, I could basically do the same exact things, and it was way more convenient and way more smooth. Like, you can make it yourself if possible. It's just really annoying.
Exactly.
Like sometimes when you break the fundamental things, and you have to spend 2 days doing that instead of making anything cool.
Right, you get the idea. It's like here, if you take CST 325, you spend a whole semester learning how to make a graphics engine from scratch, basically. And that's like cool if you want to learn what's going on under the hood. But then the first day of 326, you do the exact same thing as the final project in like 20 minutes. It's great. So that's the sort of power that you get. So that brings us to the topic today, Godot. It is a free 2D and 3D general purpose game engine. It is lightweight. It'll take, probably less than a minute for you guys to download it. And it has all sorts of fun features that are going to be useful for us specifically as students and hobbyists. A few things you need to know. A game is built up of scenes, and those scenes are trees of nodes. And there's lots of ways to communicate with them, but one of them is the built-in signal design pattern. And I'll explain what that means later. So if you have already downloaded it, you will see this. You'll see being able to open up a new project, and you'll be greeted with this lovely window. If you're familiar with engines like Unity already, a lot of this stuff will look familiar to you. You've got a scene panel, you've got the inspector, a file system, your viewport, and your script editor. The nice thing about Godot is it has an ID built right in. So you can just start coding. So let's start at the bottom left. That file system is where you're going to store all of your assets. Typically, you will have different folders where you store your scripts, your art, programming, different scenes, all will be stored there. Right above it is the tree view. Now, that's where you're going to have whatever scene you're working in. It's going to have lots of nodes in it. I'll explain what those are in just a moment. In the center, you have your game, or a scene view, rather, and you have different ways of looking at it. So if it's a 2D scene, you can look at just a flat plane. If it's 3D, you can look all around. You also have access to the IDE and a few other features. And then, like Unity, on the left you have an inspector where you can look at the properties of whatever thing you're looking at. So, scenes, that's sort of our bread and butter. Everything in Godot is a reusable scene. So everything from your character to enemies to the environment to UI, all of it is a scene. It's very flexible, And if you're familiar with how prefabs work in Unity, basically it's that plus the way they do their scenes. Very powerful. It makes everything very modular. Think of it as Lego sets. These Minecraft sets are actually a really good example here, because each one of those sets is composed of individual bricks, which in this analogy are the nodes you use to build up that hierarchy. And then together, you're able to compose a unified experience. So what does that allow us to do? Like I said, everything is modular. And you can even have just one node in a scene, say a button or, I don't know, your character. It's also like having everything divided into folders, and the nodes are files inside those folders. So nodes themselves are very cool. In Unity, you have game objects, and then you have components attached to them. But Godot streamlines that and makes it so that every piece of functionality, from rigid bodies to collisions to sprites to models, all of those things are individual nodes that you can keep track of. And on the right there, you can see how you would compose those together to create one bigger object. Like I said, these are like your Lego bricks. Assembling them together into more meaningful objects is sort of the name of the game. And so one big aspect of learning how to use this engine is just learning the various pieces to put together. But thankfully, a lot of them very powerful. I'll introduce you to those shortly. And of course, game objects plus components. That can get a bit confusing. I know when I was learning Unity, that was a very confusing thing to learn. But this provides a way for you to think of everything like puzzle pieces to fit together, rather than an empty shell to fill in. And so composing these together is very powerful. If you want to take a look at this YouTube video, this goes over 200 different types. Yeah, it's pretty incredible. And then, of course, that brings us to programming. So Godot has a built-in language called GDScript. It's very similar to Python, but it also supports C#, C++, and visual scripting. Although that's not really as fleshed out as just doing things in GDScript. There are some limitations. For example, if I wanted to open up the .NET version of Godot, or Godot Mono, and I make a game, great, finished with it. What if I wanted to make a web build? Well, I can't do that because it's not supported right now. Hopefully soon they'll add that, but for now we just have to use the normal version, unless you just want to export to desktop. And there's all the things that you would expect, in Unity and C# you have awake, start, update. Well, we have the same things here. We have all sorts of built-in functions that we can use: ready, process, etc., etc. Built into the editor, you can just start typing. You can also look at the documentation right there. So it's very easy to go back and forth between testing your project, making small changes, and iterating really, really fast. And of course, all the normal debugging tools you would expect from an IDE. We also have something called the asset library, which is a fun way for you to find resources, be it programming or example projects that other people have made, and then add them to your machine, to your project. Some really powerful examples are Dialogic and Phantom Camera, which is Godot's equivalent of Cinemachine. It's very much like the functionality of the asset store in Unity. Questions?
The description you gave.
Yes.
How fast is the iteration? Because I know one gripe that I have with Unity is it has to rebuild the domain every time.
Yeah.
You know what I'm talking about.
Yeah.
How fast is that?
So basically everything until you get to like a mid-sized project is going to be faster than Unity. Opening up Unity takes what, like 5 minutes on like a normal machine?
More like
So a friend of mine has been working on a project for over a year, and all of those like hundreds of assets that they have, all these like crazy levels, it opens just as fast as like a blank Unity project. So it's a really, really powerful tool to, if you have an idea, you just want to hit the ground running and go for it. Right. So the sort of powerful thing that game engines really help you do is manage subsystems. And that's just a fancy way of saying, well, okay, there's all these things that you don't really want to worry about. Input, graphics, sound. The most important thing, of course, is being able to control your game. So it's pretty easy to define an abstract word like jump, move left, and then associate that in your code with that abstraction. If you're familiar with how the new Unity input system works, it's literally built in, and it takes like just a minute to set up instead of having to write like a whole separate file and all that business. It's really great. So the next system is Signals. If you know what that design pattern is, the observer, this is that functionality built right into the system. So what you will do is you can go to your inspector tab. You can go to any node and ask it, okay, so for example, let's take an area 2D. That is going to detect if some body enters or exits, or any number of other things. And as most of you know, sort of detecting those collisions for triggers are like the basis of a whole lot of systems. So you can go in and just hook that right up to your code without even having to really think about it. It's a really nice system. And then, of course, you have physics and collision. There's, of course, in any game, two different systems going on here. You have meshes or sprites that represent what you see visually. And in order to interact with the physics systems in a meaningful way, you have to give them shape, physics collisions. There are two different systems that are mostly separate. The 2D and the 3D have completely different engines. The fun thing about this engine is the 2D aspect is almost completely fully realized, whereas the 3D stuff, they're still working on a lot of it. But since 4.4 dropped like last week,
It's not about edit. I mean, it's slowly getting to the point where like the lighting is like
Yeah.
getting a lot more, or like matched with its Unity. It's like, yeah, no, it's like I'm really happy with what they were able to do with the new update,
right.
especially since the entire fiasco a couple months back with Godot.
Oh, right. There's some lore there. But let's see. Right. So all the things that you would expect a modern engine to do, they are getting better. And the relevant nodes in this case, you have static bodies, rigid bodies, kinematic bodies, and basically all that stuff you would expect from Unity right there. So you also have collision shapes. You can raycast pretty easily. And then areas are sort of the solution for figuring out where things are colliding. And then, of course, you have your audio systems. I don't know a whole lot about the audio system just because I don't know anything about like music or sound, but it's all built in. You have spatial audio that you can implement really easily, and even some effects. UI systems, in my opinion, are a lot easier to create because there's a separate type of node for it, a control node, and using pretty simple panels, labels, things like that, containers, you're able to make really nice looking UI without much effort. And everything is fully reusable, which helps quite a lot when you're trying to, say, make a main menu or just a HUD. Other important settings you should know about, you can set the viewport if you want to create a nice like pixelated chunky look. You can specify a low resolution, things like rendering modes, setting the input map. That's where you would go in project settings here. And you can also set the main scene where the project starts. And then there's lots more here, but here's some some honorable mentions. You can use tile maps and grid maps to make really nice modular levels in 2D and 3D. There's navigation agents for pathfinding. There's a built-in networking API, and also a pretty sophisticated animation interface as well. And so right here I've listed, just because I know many of us know how to use Unity, what some key similarities are. So, both use scenes, both support different types of development. The editors are pretty sophisticated. All the things that I'm sure all of you know about. And then here is just a list of where they differ. So Godot, nodes in a scene tree. Scenes can be anything. Prefabs are called packed scenes, or an instance of a scene, or an instance of a prefab, if you will. Scripts, in Unity, you're mostly limited to C#. But, in Godot, there are lots of options for you. Signals built right in, different panels. You can even make transparent panels, so you can do things like making a little desktop creature. Very fun stuff. Lots of documentation stuff. And then, of course, all that scripting jazz. Okay, and then this is the part where, if you have not already, here is a good time to download this starting project that I made for everybody.
How did you download it into Godot?
So that's a great question. Do you have it downloaded already?
I have Godot downloaded already. It was very fast.
Okay. There's an option when you first start it up. It's like import a project.
Yeah, but I didn't see anything in French.
All right, my friends, before we continue to the more like demonstration part of this talk, do you guys have any questions, or was anything confusing so far? So it seems like most of us have gotten to the right part. Ready for an adventure? I certainly hope so, because we are now going to open up our Jam toolkit.
I'm trying to make my own game for like my major pro 7. That's my project.
So, okay, what is the Jam Toolkit? Well, in case you guys didn't know, we are having a month-long jam in April, right?
April Fool's Jam.
April Fool's Jam! And so the whole reason why we're doing a little like series of tutorials like this is basically so that, you know, if you guys would like to make something but don't really know how to, we're going to give you the support to do that. And so the Jam Toolkit here has lots of example projects. I've included about 5. Some of them are more fleshed out than others.
Yeah, top down is just walking.
Yeah. So I'm basically going to show you like how projects are structured so that you guys can get a better idea of how to make stuff on your own. When this loads, of course. All right, so this is the editor. I've been doing lots of stuff already just to prepare. We've got like levels of various kinds. You can look at stuff in 2D or in 3D, but like if it's in 2D and there's no 3D component, then it's not going to show anything. You can look at the editor.
You can edit the scripts with
Yes.
what?
It's really powerful for that, actually. And then, see, I just switched over to menu, but I'm still on script, so I have to click over to 2D. And this is just a few buttons, basically. That's how simple that is to set up.
You're telling me I downloaded a bunch of extensions on the VS Code for no reason.
Yeah.
Yeah,
Okay, cool.
basically.
Godot is basically very streamlined, but also it basically just includes the bare minimum to do everything inside of it.
So let's try playing this. When you open up a game for the first time, it's gonna do a little pop-out menu, and here's what that looks like. So this is one of the example projects. This is a full Pong game, which,
Wow, the physics are slightly funky.
yeah,
But hey, it has physics, which is a far cry than what I've ever done.
Yeah.
Who needs
Better than
physics when it's all
better than
text?
the Pong project I made
Stop
for.
losing.
well, I mean, I'm playing myself here, so.
What?
Hey, we can always get another person up there to duel you.
Okay, so that's that. And so how I would navigate this is typically you want to arrange your projects a little bit like this, but it's up to you really. So I have folders for assets, for scenes, for scripts, and if I wanted to go to the scene for Pong, I'd have to go down here, double click that, and then this is the entire game right here. Because it's such a simple game, it exists on one scene. So the player is made up of just a rectangle and a collision shape. Same thing with the second player. The ball, also a color rectangle and a collision shape. Very simple stuff going on here. The walls, which you bounce off of, are surrounding this board, which is itself just a PNG image. On each side of the board, there is a collision area. These are called area 2Ds. They always have to have a collision shape associated with them, or they're not really going to be able to detect anything. So this is when the ball goes past you. It will give a score one way or another. And then there's a HUD with 2 labels that tells you what the score is. And then the last component is we have a timer that starts the ball after just a moment. So for this one, there's only a few scripts that really run the whole show. We have Pong, there's a ball script, and I'm not going to explain what all of this is. However, I do gently encourage you all to sort of read what's going on, try to get a feel for the syntax, and
Get Python, you can get to
exactly. So, right, we define our variables and our constants. It extends a node, and then you have certain built-in functions like ready, physics process. That one's important because it executes, I think, like 4 times a second or something like that. So it's a way to sort of save resources so you're not drawing every frame. Yeah, do you have a question?
Yeah, like I see that like a func ready and like func physics process, like
Yeah.
have an underscore before them.
Right.
Is that how you like pull up the like inbuilt stuff?
Yeah,
Just,
that
like, pop up automatically.
that is a good way to distinguish like a script that you write versus a built-in one. Yeah. So like for example, like new direction here, that's one that I wrote. Doesn't need an underscore beforehand. And then it has arithmetic, all the things that you want from a programming language. Let's see. Let's look for something more exciting here. So the level itself, this has some interesting things going on with referencing things that already exist. So $ball.new ball.
Could you zoom in possibly? Or no? Whoa!
Yeah. Okay. So
Is that just control scroll?
yes, it is.
That's so funny.
Let's see. So like, you can reference a certain item or node simply by like grabbing it and doing that.
Very cool.
Just like that. And then of course, each one of these has properties that you can access, like so. And then, same thing with this timer here. You just drag that there, and then you can set it to start. Very cool and streamlined stuff here. Let me see. The player. I think this one has some interesting things going on. So this is where we ask for input. Let me zoom in on that. So input.isActionPressed is a pretty common way to just grab an input that you've defined. And in order to define a new one, you can go up to Project Settings, and go Input Map. And I have all of these different types of input already defined, most of which, if you've ever used the new Unity input system, it is just as easy as doing that. You can define keyboard as well as controller inputs. Let's see. And then while we're here, another fun thing to look at. Oh, it's the second tab over. Okay, and then while we're here, let's look at some of these things. So you've got the ability to set the size of a window. You've got under application run, this is where you would set the initial scene when you start a project. That's kind of the two most important things when you're starting a new project. Okay, so that's Pong. Let's try the next one. Top-down RPG. This isn't really much to write about, but this one demonstrates how you would take a character controller and just move it around. So later on, I'm going to ask you guys, spoiler, how can you take some of these things that maybe aren't fleshed out and try to make something cool with it?
Well, maybe we could make like a node for monster, and then like give them a random chance to pop up. Like if you like,
We can make
have like a random timer for them.
we can make a scene from us and then that and just throw it on
Yeah,
here.
like you have to have two scenes.
Okay, so this is kind of what that looks like. So a player is just a character body, I think it's called,
Yeah.
with a collision shape, a sprite, and an animation player. And all of these things together you're able to compose into something like we saw just a moment ago. And then for the level, this uses a system called a tile map, which if you've ever used the version that Unity has, it's exactly the same. You have to define like a sprite atlas, basically, which is what we have down here. And then, you can draw. There's different layers. So if you really wanted to make, any kind of world in 2D, this is a really good way to do it. And then bringing those together, what the game itself looks like is you have the level, the player, and the camera all together. And that's the top-down RPG. Okay, let's do the next one. So the next one is a 2D platformer. If you guys know Brackies, the educational YouTuber, this is just his tutorial on how to make.
Wow, you turned on the sound of it.
Yeah. Actually, genuinely, I'm not sure how to do that in testing mode. Okay. Okay, yeah, that's better, for sure. So you have enemies, you have things you can interact with. And all of this is built also with a tile set. And then...
There's like multiple, like digital objects. Like, how is that done if each of them are their own, like, node thingies? Because I presume you don't have, like, 7 of those in there.
Well, okay, so that is a really good question. Let me show you how that works. So if we go down to our 2D platformer, we have all of these scenes. You remember how I was saying everything is a scene that is instantiated in another scene? So we can go to the game, and so this is what it looks like. If we wanted to add a coin, we could open up that scene, and this is everything that defines it. It's an area 2D, an animated sprite, collision, the sound that was piercing your ears, I apologize, and also the animation player. So this is everything that defines it. You can almost think of it like in object-oriented programming when you define a class and you go to make an instance of that class. That's what we're doing. So you can go over here and take that scene, which we were just looking at, and make an instance of it in the larger scene. And doing that, you can compose things in a really nice way. So like looking at the player here, that's pretty simple. You've got the slime. There's some interesting stuff going on here with raycasts, which in 2D are very, very easy to do. They are themselves just nodes. And what it does is it will go back and forth until it hits an object. And then when it does detect that it's hit something, it'll just flip and keep going.
Question, like, I presume there is, like, how would it work to have something within the system that makes more objects? Like, for example, a monster spawner is like a
Yeah.
basic version of that.
So you can do that all programmatically, right? So if you have a reference to like a certain type of object, you can basically say, okay, make a copy of it at whatever location. I don't think I have a good example of that to show, but that is definitely something you can do.
I mean, one like a physical one, it's probably like seeing a timer for the scene, and that would have to spawn right next to it.
Because frankly, I'm thinking of doing sometime soon a very easy and fairly obvious board shooter. Get those little like clicks happening in your brain. So I already got a system to make spells in the other game I made and give them randomized spells,
Mm.
which we'll call it.
Yeah, you could definitely do something like that. So what we have here is something I think would be fairly easy to make your own. And like I said, this is just from some Brackeys tutorial. Feel free to follow that yourself and get a deeper understanding, or just replace the tile map and the player and make something on your own. That's probably a good way to make a first game if you've never done that before. Right, okay, let's move on to the next one. So actually, let's do some house cleaning. Oh yeah, I'll show you that one in just a moment.
Oh, evil, the third direction.
This is like when I have too many Chrome tabs open. Okay, let's look at the next one. So this one is kind of interesting. Whoa, hello there. Yeah, okay, so if you know the game Doom from the early 90s, that's what this is. Well, that's not very exciting. How do you think we can make that better?
Make it faster.
All right.
Guns and then have them interact in interesting ways when chained
Give me an
together.
army of those guys.
Okay.
Like, for example, have a nailed gun that when you shoot it with an electric weapon does more damage.
Okay.
All right. So
Interactions.
you're saying we need more enemies. All right. So we can go Control D, Control D, Control D.
I feel like they also should die.
Control D. How's that for a challenge? Huh?
Basically, guys,
Do they do anything when they touch you, or do you just like
oh
not
yeah,
You die
You don't
forever.
know when you die.
Okay. So that's a bit of a challenge, isn't it?
Stop being good and die. So you can see what that is like.
Okay.
Stop being good is
Okay. So whoa. Oh no.
What happens when you touch them?
Let's see. Oh no, you died. That's no good. Okay, well, I guess we're just gonna have to, solve this the old-fashioned way.
I wonder how a headshot would work.
This one is very goofy, I will have to say.
They instantly have their head system.
What if they get back up after
Oh, that would be terrifying.
Turn.
I'm gonna leave that as an exercise to the reader.
It's so funny how their corpses keep turning, so they're always the same direction.
Good old billboarded sprites. All right, so this one is actually incredibly powerful because this is kind of the simplest possible 3D game you can make. If you are interested in doing any type of story-driven thing, say like a Danganronpa clone, you could do a fun thing where maybe instead of killing these guys, they're like, cute little like anime girls, and you have conversations with them. I don't know, just an idea. And I have a special treat for you guys. Included in the package here, there is an add-on for a system called Dialogic. And
Oh,
this is a really powerful tool to... here we go. This is a really powerful tool to write dialogue. To be quite honest, I'm not entirely sure how it is used entirely, but this is how we were able to make the text boxes in Catscape really easily. Yes.
I'm not using this project that you have lovely have made for us, but I'm trying to get Dialogic in
Yeah.
here with Asset Library.
Okay,
It's not
so-
showing up
It's
in search.
it's
Is it
not an
on Git?
asset. It's something on GitHub.
Yeah.
Okay, I'll look it up.
This is just a thing that you're gonna have to like go to the GitHub and add to the project. Or you can just steal it from the example toolkit here. Because it's pretty easy to just copy and paste stuff between projects. So I encourage you guys, especially those that are interested in more narrative stuff,
I'll put it in general.
yeah, please, play around with this editor. So it's got like a Scratch type interface where you can make these things. I don't really exactly know how to use all this yet, but I've seen how powerful it is. And there's a lot here to help you with that. And the documentation looked pretty good. So that would be Doom. But actually, let me show you more how that works. So each, this is just the level. It's made up of the player, and if you're in the scene tree, you can just press this little scene button. If you've made this kind of stuff in Unity before, this should look familiar to you. It's just a capsule with a camera, and then this really long, obnoxious thing is a raycast that goes basically infinitely far away. And so why do we use a raycast instead of trying to make a projectile? Well, it's cheaper and easier. And if you don't care about a delay between like shooting and it hitting a target, that is what you would use. So we've got some UI stuff here. There's some really cool stuff with the animation you can take a look at. It's just 4 frames, and in the script, it, let's see. Oops. This is the script for the player. Oh God, what have I done? Here we go. So this goes through how that's organized. When you shoot, it initiates that animation, and then here we go. It initiates that animation and then basically waits until it's done before you can shoot again. And then it has a sound associated with it. So, the possibilities with this stuff are really endless. Okay. And the enemy, here we go. So the enemy is just, what's it called? A character body. And it has a collision, so if you collide with it, then it kills you. It has an animated sprite 3D, which constantly loops through 4 frames of animation. And the nice thing is, if you're a big fan of that Doom art style, somewhere in here there is, here we go, a flag for Y billboarding. And that's a built-in way for you to achieve that always looking at the camera art style.
Huh.
Yeah.
I wonder if you could do some creepy shit with that in some games.
Oh yeah, absolutely. And then of course there's a sound associated with it, and that's really it. It's
Is that guy black?
yeah, it's just a sprite.
What you call it? I was wondering because there is a 3D space and the capsule makes me think of the 3D.
Right.
They aren't actually drawn 3D.
Yeah, exactly. And so if you're interested in designing 3D games, but you don't really want to bother with making 3D models, this is a really effective way of going through just drawing things in 2D, is probably more intuitive, and then chaining it together. So, and then of course, there's different animations here. So there's that death animation you saw earlier that was kind of weird to look at. Okay, so that's pretty much all for the Doom clone. And the last thing I want to show you, I think is pretty exciting. This is a third-person platformer controller. So this is pretty powerful if you guys are making, say for example, just an environment in your choice of 3D software, say Blender. So if you want to export, whoa, why is it shaking like that on the monitor? That's crazy. Anyway, so if you want to just make a level and plop this this character inside of it to explore, much like the Superman asset from the Unity store, super character controller. If you guys have seen that, that's basically what you can do with this. So this is not exciting on its own, but if you're interested in making 3D levels and you just want to explore it, this is a good option for you.
Funky, they don't have
Thank you for coming.
the usual, like, goodbye. Oh, funky, they don't have the usual shadow that's right below you.
Yeah, a
It's
blob
an
shadow.
actual shadow that does things.
That's also pretty easy to implement. Let's see. So,
I understand people also get freaky when they can't do proper depth perception stuff.
right. Okay, so the level is just all this stuff right here.
Make a circle makes it rotate around.
Here we go. So this is made up of two main things, the player and the level. Okay.
Yeah, like, here comes the sun. It's like on top of their finger.
Doing the way that top one, it's like lighting just doesn't make sense to my brain. Why the hell?
Oh, I'll show you what that is. So this is,
The trail?
it's the camera.
What?
Yeah. So this is a good example of
If it was a young Grey, it would
nesting scenes in other scenes, I think to 4 degrees. So you've got,
yeah, just imagine if like the sun.
oh god. So you've got the skin, which is basically the mesh. This is just the visuals, and it's animated. I did not make this, by the way. This is like a open source type character associated with the engine. Very cute, right? But okay, so that
That seems like a complicated iOS.
leads to the 3D character itself, which takes the skin, the mesh, and combines it with a character controller, which is what actually takes the input, processes it, and does the physics. And we also have this funny looking system. It's a camera pivot attached to a spring arm attached to a camera. And so a pivot is just an empty object. The only information associated with it is position, basically. And then the spring arm basically links these two nodes together, and then it will like go back and forth so as not to like collide with other objects. And then the camera is pointed at Sophia here to look down at her all around. Pretty good stuff. If you, any engine you work with, gonna look similar to this. This is just one way to do it. And then, of course, you have all these sounds. You have particles that are created when she moves. That's a nice little touch. And then a collision. And that's pretty much it for her. So you can plop her down in any environment and safely be able to explore. Okay, so with that, that pretty much covers everything in this Jam toolkit. And I would like to finish off by asking you all to go on a quest. And the quest is make something cool.
I remember that little webcomic. It was adorable.
Yeah. So you can use the provided files. You can make something on your own. I invite you, please, express yourself in whatever way you see fit. This is a really fun medium to explore different perspectives build empathy, and so on and so on. All the fun things we associate with video games. And that pretty much covers it for the presentation. Woohoo!